So if you don't see my screen, please tell me. I see it's in sharing mode. If you don't see, please tell me. So I will talk about like applications of artificial intelligence in multi-billion search engines. I will explain what does it mean, and about building AI and search team. Why I'm talking about this? So currently I am leading search and conversational AI in Zillow. Before I was leading search science team in Walmart and eBay. I started my search career in Google, in early Google in 2006, when we actually just built Google as the first search engine, like most prominent search engine with the best quality. Then I worked in Apple, where I built Apple Map search, and then I was co-contributor to iTunes, AppStore, and Apple App Store search. And I also was founder of the startup Ozlo, which was acquired by Facebook in 2017, and it was also conversational search startup. So my search career is since 2006, after my PhD in computer science. And basically, I'm working 15 years in search, and I'm trying to share my experience. I'll move to the next 1 second. So my goal of the stocks, my goal for the stocks is to explain how AI and ML in search engines improve customer experience, revenue, operational costs, and helps to get more customers to serve them better. How to build AI systems for search, and also how to build good global AI teams and how to make them successful, how they can build big search engines. So my main message, to summarize what I will be talking in this presentation, that successful AI applications in search is not just some set of state-of-the-art models for some particular topic like query understanding. Actually, a successful AI in search is artificial intelligence infrastructure, engineering and science, culture and tool sets, enabling continuously introduce, measure and improve AI features in every part of search engine stack. And I will explain, give several examples and AI is useful everywhere in search. The same true applies to every large-scale consumer or business-facing platform, not only search, recommendation agents, call center analytics, anything benefits from AI a lot, but not when it's part of with certain model deployment in certain part of the stack, but when it's applied everywhere. And if you want to build such AI solutions like multi-billion search engines with AI applied everywhere, there are certain requirements on teams, how you want to run these teams, how you want to build them, how you want manage these teams and so on, how you want to hire for these teams, and I will explain it. What means multi-billion search engines? So if you want to build small search engine for let's say forum search for your company, you don't need all this stuff, right? You can just install any, you can use any search as a service solutions. There are several of them. You can build some simple search engines. There are several of them available. You don't go into this complexities, but once you go to big search engines, it's managed multi-billion sales of your e-commerce platform or real estate or web search engine, right? Or App Store, and not minor, but improvements of search means billions of dollars improvements for your company. Then suddenly you get into this complexity, how to run a system enough which will enable you all this development. And my presentation is more about running these big search engines, which has multi-billion revenues, such that improvement of ops or query understanding or indexing will give you much gains in hundreds of millions of dollars to justify these big teams, to justify big improvements, to justify work on AI and applying AI within these search platforms. So this very high level search engine, typical search engine overview. Of course, it depends, depending on your search engine, can be quite different, but typically search engine consists of data acquisition. It can be as you crawl or get some feeds, public and not public. You have data acquisition when you get data from providers, you process, normalize them, deduplicate, cluster them, and you store them. Then, of course, internal data as a very important source. You consume them. It may be consumer behavior data. It can be for example, click logs, search, click logs, sessions on your website. It can be some business data insights based on sales of your company. You process them, you normalize, you train models on them. For example, learning to rank relevant models. Learning to rank relevance models are frequently based on behavior data, and there are multiple other uses. You merge them with external data. You build index feature representations, which you serve, deploy, such to be by runtime component of your search engine. And typically, search engine, you have user interface. You have search assistance services such that as type ahead, such that as different filtering conditions, facets, query understanding, which makes semantic understanding of your query, retrieval system, which retrieves results, a ranking system, which ranks them appropriately, UX representation of results, which creates snippets, creates different page representations. For example, your search engine can combine results from multiple corpora. You have search engine for, let's say, for for example, for videos, for apps, for music, and you combine them, how to combine them. There is certain logic. And of course, it's also AI can improve this logic a lot. And then you build user interface out of this. So this part more like runtime serving of search engine, and this part is more like data pipeline serving it. And they, of course, all integrated together. And it's not full diagram. There are a lot of parts missing here, like experimentation, other frameworks, evaluation, logging, monitoring, alerting, which are equally important. But I just did not put them here just because of lack of space. But it gives you representation how complex is typical search engine, a modern search engine to serve once you have billions of users, you need all this stuff to handle it. And AI is everywhere. So basically, if you consider, I will give several examples. If you consider this framework, then typical AI applications are almost both in runtime stack, in query understanding, in ranking, in retrieval, in search assistance, in of course here, you train those models, deduplication, clustering is AI, data enrichment is here. So AI is everywhere in this stack. And you get measured benefits for your business from applying AI, not like if you focus somewhere on one stop, like query understanding, and you will do a lot of AI improvements here, but if you train models and make AI applicable everywhere in your search stack. So if you improve each of these parts by 10%, you will get higher benefits for your business, and can be different, like customer satisfactions, revenue, like how much people pay per session, operation cost is also important for such big search engines, rather than you focus, let's say, query understanding, and you will be applying, improving sort and sort in some particular state-of-the-art models in some particular areas. So once you develop such complex systems, it's super important to make AI be available everywhere. And AI, it will be not just only set of deployment models, deployment tools, but whole infrastructure, culture, and tool sets how to apply AI. So AI is not separable from engineering. It's not like you make and focus how the most complex models you can be used, right? Because AI is intermixed with engineering. If you improve certain index selection by 10%, it's let's accommodate more data to improve coverage. If you improve the infrastructure to decrease latency, by engineering efforts by 10%, it will let you to deploy more sophisticated ranking and query understanding functions. You will get 10% of more time to do your more complicated models, and you will get another benefit. So basically, it's very important for once you develop search engine, not to focus only on AI development, but to focus also on very good engineering culture, and it will help you to improve, get more benefits from AI deployment for your business. One is ways to have separate teams working on separate part of search engine to develop their own AI solutions, but actually your team developing search engine will benefit a lot if you have different AI run clubs. It mostly means training AI platforms to AI platforms which work in runtime infrastructure. So having such labs and platforms such that teams can share the experience, use unified set of tools, share models, share deployment scenarios will benefit your team a lot. And search systems are naturally complex by different tasks, different environments, different languages, different CI/CD systems. So we'll never have just one AI platform, but making organic growth of AI solutions into platforms helps the development of your search engine a lot. There are multiple ways how to deploy AI models in search. Certainly, some of them can be in runtime, some of them going through such TensorFlow, torch serves, some different ways. Some models can be deployed in containers, some models you compile because of high performance directly into machine code. And there are different ways how you do this, and then you execute during runtime. There are multiple deployment scenarios. That's why there is no one AI platform to serve all of them. Some ways, some models you serve in streaming, when documents updates coming and you want to serve them offline. Some you do in batch processing. For example, when you process your behavioral data, some of them you do serving runtime, for example, query understanding for each consumer report. So there are very different ways how you serve AI models. And again, it makes hard to create one AI platform which will serve all of them. So it's naturally that you have multiple deployments and serving scenarios. And there are multiple ways how you improve AI in search. You change evaluative methods and metrics, and you train models to new metrics. You change sampling procedures, you change training procedures, you change modeling techniques. You model tags which you previously did not model. You add new data and features. You do infrastructure changes and serving. So there are multiple ways how to improve AI in search, and typically all of them actually can benefit your business a lot. So it's almost impossible to make one platform to handle all types of AI development and deployment and search. But like as your team develops the AI solutions, it's organic process to make them grow into platforms. So several teams develop different solutions, but then you see a lot of sharing and you build AI platform for this typical scenarios there. Or you can use also like some open source ML or AI platform and build on top of this. So this organic growth and unifications helps you to share experience between teams, to share knowledge, share models, share data, share different engineering practices, and so on. And there are like a lot of platforms now available on the market to start this development. It's good to have AI services in production decoupled from each other, so multiple teams can work on services independently. A ranking team can work independently on query understanding team. It can work independently on like index selection team, right? So they don't need to go into code with each other. They can work in parallel. But of course, all these services should be interconnected, like signal feature from query understanding can be used in ranking and so on. So it's important to build these different services that the different teams can work independently from each other, but they should be interconnected. So if you have a new signal from query understanding or from document, it can be available in ranking and so on. So to build these wire services between different AI serving scenarios. Typical typical processing of query may call dozen of AI services different to understand query. If you want to understand document, your platform may call hundreds of different AI models. So this kind of complexity consideration is important also. And AI infrastructure benefits greatly from common software practices, protocols, orchestrations. Yeah, I will go like, again, there are a lot of objective functions, how you build your platform, how to optimize them. It's not just only about AI accuracy and different metrics, it's also like how to handle them. Latency, resiliency through output, resource utilization, all of them are very important in applications of AI in search. You have very strict definitions, you have very small, like for example, for on time, you have very small, you have certain latency requirements, like you may give 20 milliseconds to your models. You have a requirement, it may be like 20,000 queries per second your AI platform must be capable to process. So those are very important factors as you build AI platforms for search. So next I will give just several examples how AI models is used in search to demonstrate that they're used everywhere in the search stack, but it's not comprehensive. So original my slide presentation was around 170 use cases, and I just cut it into very small, maybe even some of them not the most important, but just to give small representation how AI is used in search. So indexing perhaps was first AI application in search. Once you get a huge index, right? Not all documents are actually good to serve. You don't just increase size of the index. You want to have high quality for index. And how to select right documents in index. How to evaluate this document is important to be served or not. This one of your applications in search is index selection. How to understand that these two documents represent the same item, maybe the same property house, the same business, the same web page, right? There may be just little different copies, the same e-commerce product. So to understand duplication is another AI application and such. Attributes extraction. So assume you have your search engine about e-commerce or about properties, houses, and you have full text documents. How to extract attributes information from the document about your items. So how to understand, like if you have description, like, you know, this is a French restaurant in downtown Palo Alto, to understand Palo Alto is location, downtown is clarification, French is a type of, French is a type, restaurant is type of the object, and so on. How to do attribute extraction, how to map your unstructured text into structured representation of information. A lot of statistical tasks about how to evaluate size of the index, how to understand index code coverage. It's more like statistical task but related to AI also. Data quality, so like globally, how to understand which attributes are important must be mandatory, which attributes can be optional in data acquisition. It helps, like once you get this information, to drive your business data acquisition efforts a lot. And I applied in one of previous companies, and it saved company a lot of money, not just in data quality, not just in search quality, but also in like working with suppliers and vendors, how to provide data, how to make such that you pay them for only necessary data instead of paying for huge information or if you don't care. And there are spam, fraud, adult information, content detection, all important efforts in indexing part of search engine. Demand generation is another application. Query understanding. Given a query, someone comes to your search engine and types like 56-inch Samsung TV. So how to understand that Samsung is a type, TV, Samsung is a brand, TV is a product type, 56 inches a screen size. To understand the query and not just like parse it, but there are multiple other important things in query understanding. Classification of queries and query understanding. Given a query, like in local search, Italian, how to understand that most probably it means Italian restaurant. Or if you have like French, it means restaurant most probably rather than French laundry, which is type of laundry. Understand distance which user care for this particular query in local search. Or in e-commerce search, when people type printers, for your ranking, it's very important to understand that for printers, people care more about recently released items than for pillows. They don't care when item was released, right? So it's another typical AI application. And in big search engine, you have hundreds of classifiers per search engine with significant impact on quality and revenue. How to understand that these two queries represent similar information, right? So they're like, and you can use this, like if you have information for one query from previous behavior of users, you can apply it to another to deduce ranking. Entity attribute extraction is also very important part of query understanding. Next part of AI is AI for ranking, how to rank your results. Once you retrieve results, what's the best ranking of results if you want to maximize either like conversion or like there are multiple metrics which you apply in optimization your search engine for business. One, of course, you care about total revenue, but then you care like how many different items users buy, or like user satisfaction is not always directly related just to how much users spend. It's related, but not directly, right? So there are multiple ranking objectives, and AI is typically used to optimize your ranking solutions. Search assistance, you want to help users to type results faster, to do less keystroke. It's very important for mobile devices, especially, right? How to give them suggestions of queries. And then also how to create good navigation panels and guide them through different visual elements is another important part of the application AI to search. How to create whole page, how to combine different like search engines, which typically like in big search engines, you might have multiple of them, how to combine an order of the search output. It's also AI application in search. How to create good visual representation of results. So you might have like an image, you might have like item title, you have big descriptions, how to select proper words to show on your page such that it will give the best user experience. User can understand is this result they care or not without clicking on it. And like it will help you. And actually it's surprising how much conversion gains or revenue gains you can do from search result page snippet improvement. Then it's like related like price prediction. What's the best price prediction for your item? It's not directly part of search, but it's related to other search functions. And it's another important part of your applications in commercial search engines. And there are more like complicated cases now, like conversational interfaces for search. They're kind of new emerging applications, very promising, not still big from consumers and revenue points of view, but another like how to do dialogue-based conversations. It's new emerging applications of AI in search and very promising. And of course, integrated with automated speech recognitions, which are typical voice-based systems now. And then many search engines now, they have a post-search, right? Once you search, you can save your query. And then we want to notify what the best like items for your search result which recently appeared, or maybe like there was a drop price on some items you care about, right? And it's also AI applications. We don't want to send you too many messages, but we want to send you relevant messages such that will cause best user experience and best conversion for you. And next, how to build search team which will be will like build such big complicated solutions. And search teams like to serve this search engines multi-billion, usually quite big. So I will describe, and there are kind of, like there are a lot of connections, but there are two different types of search engines now. One is like Google, which are just focus searches in the main mission. Others like, Zillow, Trulia, Walmart, eBay, where search serves you some e-commerce experience, right? And there are like kind of little bit different requirements because first time of the teams, they're more connected to business. So I will focus more on the first types of search engines rather than purely search engines. But there are a lot of commonalities, of course. So do you need to buy a search team, right? Because some companies buy search software as a service. Some companies ask consultants to be search engine for them. And it works if search engine is not core of your business, right? If like, for example, just web forum or like customer complaints search is kind of like serve your business, but not really important. You don't get direct revenues from that. You don't really care much, maybe in some cases for quality of search, so it's fine, right? But when like all your multi-billion business and satisfaction of hundreds of millions or billions of users depends on your search engine, the only way for now proven to build your search engine is to have your own team, which will care about this, which will build it, which will build AI inside of this, which will build everything inside of this, rather than relying on external services. Like there was like good business value which Tim Cook declared when he can become a CEO of Apple. We believe that we need to own and control the primary technologies behind the products we make. So if search engine is a primary technology for a company, the only way to work with it is to own and control it rather than applying to software as a service or any other external solution. So there are multiple critical roles in search team. I'll describe some of them. I'm missing some of them, but it's kind of just high-level representation, right? The exact composition of your search team depends on your business. Some teams can be more heavy in ranking. You need more like AI engineers, MLE engineers who are busy like with building learning to rank solutions. Some search engines may be more like, you have to integrate your search engine with availability systems. You have to integrate with price systems, multiple other systems. It's like more typical for e-commerce search engine, and like ranking, maybe you don't have that big set of results, and it's more important to integrate this system, integrate your ranking and query understanding, rather than just to have complicated models on ranking. It will be more backend engineering heavier. So like there are different compositions of the team depending on search engine. What very important to have that all roles in search team are aware about AI, understand how it works, and not only technical but also non-technical roles. It will help you to apply AI in search engine at scale a lot. So first, like important set of skills in search team is search infrastructure. As you build your search engine, like from scratch on C++ or whatever, right? What we did several times before, or you use some open source, Sol or Elasticsearch. It's very important to have a lot of skills in your core team, which understand this technology deeply. Because a lot of improvements will come for your search engine from performance, operation costs, resiliency, and how to build this. You can imagine if you run search engine, right? And it goes down for like, let's say 1 hour. Depending on your case, your company may lose like millions of dollars, dozens of millions of dollars and more. So how to make it resilient? Performance, right? It also becomes very big part of your cost. Do you need like 100 nodes to run your search engine or 1,000, right? It costs a lot of money, operation cost. And then can you handle your user request in like 200 milliseconds or 1 second? It will change a lot of user experience. So performance becomes really important, and actually user experience also directly affects revenues of your company. So having such infrastructure skills is one of the super important skills which you want to have in your team. And of course, it may not only understanding software, but frequently it means a lot of particular algorithmic improvements. So for example, how to design efficient index structures, how to design efficient fuzzy match search algorithm, it's important to have skills in that particular algorithmic area. And you need experts in this. So search infrastructure is one of core skills for the team. Search quality, and it's more like kind of AI heavy. It's like how to understand queries, how to rank results, how to build proper applying of AI and indexing. Search quality consists of multiple subcomponents like natural languages for query understanding and document understanding, also machine learning based ranking and other, right? So you need good machine learning engineers, applied scientists with background in information retrieval, search, learning to rank, NLP, natural language processing. And that's like another core set of skills for your team. How to do this, how to apply the skills, how to drive search engine AI applications development in search engine. You need a, I would call it search quality or search science team. And like I noticed from my experience, people who just know how to train models in R, they're usually not really building a lot of new search improvements. It's very important when you hire such people for your team to have them also good software engineers, not just applied scientists, but also a good software engineer, what typically call machine learning engineering type profile. Not just scientists, but also build, because a lot of search development will be not just deploying new models, but also building new systems within your search. Of course, operations SRE like super important for your search engine, right? Don't forget, typical search engine is core of your business. If it goes down, customers cannot find whatever they want, however good your models. And having good SRE ops team who can operate a high load, complex distributed systems, again, so many of the search engines who have like tens of thousands queries per second. You have like systems which runs on thousands of nodes, multiple dependencies on other systems. It's very important to have good SRE operations for that. And there are multiple dimensions of this complexity. It's not just system is complex. You have more you have big teams of search scientists which deploy multiple models. It's continuous streams of new search improvements every day. How to build good DevOps such that you can do this continuous improvement, continuous production deployment in your system, reliable, resilient, monitorable, and so on. Of course, user interfaces are super important for your search engine, right? Everybody talks about learning to rank and query understanding, but satisfaction of your customers and revenues is also depends on a lot of user experience. I saw surprisingly trivial UX changes which were bringing huge conversion gains and revenue for the company. Like you change a color, you show off the item in your commerce website, and then actually you get a big improvement in conversion, right? So having skills to build an experiment with such like data-driven UX is important skill for a search team. Search pages are necessarily complex. There are many search results. There is a lot of information search result. So how to do like data-driven UX development is important, and also important to have full stack engineers who know how to build stack from search engines, API, query language to the final rendering of the page. Product managers are very important skill set for a search team, right? There are multiple roles how product managers play, and all of them very important. And actually, I saw when they're not good, they can actually screw your operations quite a lot. So like typically product, like if your search engine is business related, you will have continuous stream of requests from business. They want to add more information. They want to add a new type of search. They want to add new filters. Some of these requests are like good. Some of them actually not, because business does not have full visibility how users operate your search engine, how users get benefits, right? And product managers must be capable to understand these business requests, prioritize them. Sometimes say no to business when actually it will not bring benefits. So how to create good connection between business and engineering. That's very important also for good engineering, because frequently you get a lot of new data from business which you did not know about. So having this continuous stream of requests, and also like requests from engineering to business, and creating good connection is important for product managers and search engines. Oh, sorry, wrong one. Like how to build proper search metrics, which will reflect true interests of business. So how to take business requirements and put into search requirements such that can be used by engineers to improve search engines, models, and so on. It's another important what typically product managers do. How to working with engineering leadership, build a roadmap which will help to improve search metrics, but take into account technology constraints, efficiency, and so on. So it's like building a good PMS search requires deep technical skills and business understanding and communications from both sides. Statisticians, how to design, explore, like working with like search engineers, how to design proper search experiments, how to understand them, how to get insights, what was right, what was wrong, how to analyze metrics, how to analyze customer behavior and get insights is another important skill set in search engine development. Data engineering, of course, typically you have search engine produces billion of customer-based events per day. It consumes billion of other events like web page or other items update per day. How to create good data pipelines which will process this such that you can deploy complicated data processing in these pipelines is another important skill for search engine, and how to run search team effectively. So I saw several very important things. Of course, there are multiple more, but I'm already out of time, just 2 slides more. So several important things. First is like very important to have highly dedicated team. Invest a lot of in continuous training and professional development in every work streams I described, right? It's very important that they understand each other, a lot they understand, and everybody continuously improve both in their area. It will be as AI, data engineering, or like ops, but they also understand quite a lot of what other teams are doing. All education efforts pay back well. Investing heavily in good collaboration culture, visibility, alignment. So search team does not work well like when you work them in silos, right? How to create a good connections between each team to every other team, creating a click of connections. In search, everyone may surprisingly find performance of everyone else or hurt if something done wrong. So it's very important to create high visibility of teams into each other business, into each other set of technologies, each other set of metrics to have strategic alignment between all teams. And it will keep people happy, also very important consideration. Invest heavily in engineering culture. Like search engines are very complex system, necessary like hundreds of components, thousands of components. I believe at a certain moment Google, as example of search engine, was the biggest by number of lines of code system. And such system cannot function well without high quality of engineering, and there are multiple aspects to that. And people are more happy when they produce high quality stuff. And invest heavily into experimentation, infrastructure, and culture, such that everybody can contribute, everybody can experiment. What would be like AI team, data engineering team, UX team, everybody can experiment, try new solutions. There's a lot of search engine improvements who come from this grassroots experiments when people experiment and create new stuff. And of course, it's very important to create high visibility what your search team, how it works, and with stakeholders, with your businesses, with business owners. You know, like typically the more complicated search, the simpler the output, and people think that search is something simple. Despite to create the simple output, you have like hundreds or thousands of systems working behind, or thousands of AI models and so on, right? To create understanding of business owners, how search team works, why these results are there, what was improved is another very important investment once you're on search team. Yeah, I finished my presentation, so I'm ready for questions. Thank you very much.
Yes, thank you a lot for the presentation. We have 3 questions in the QA section, and one of them is on suffix arrays and trees. Where do we use it? Saket has asked the question.
Yeah, suffix array typically like a lot of used in type ahead after suggest. You get a lot of actually a lot of developments within like last 10 years how to do much faster fuzzy search. They used then actually there are new ways when you build 2 different trees from beginning and end. So they used a lot in type ahead and also in query understanding. You used a lot of them.
Yeah, and there's another question on, can you dive deeper into what to look for when hiring a product manager? I think we will not be able to get into details, and I will request Dr. Lopatenko to be available offline.
Yeah,
question, because that will be diving deeper. We're already 3 minutes late. That's why.
Oh, yeah, I would be glad to answer online.
There are 2 questions, I just want to make sure I mentioned that, and people are asking for slide deck and so on. We will respond to them offline and on the chat. Top 3 mistakes organizations can make in implementing search is another question. And unless you can immediately say count three items, let's adjourn for now. And we have 10:50. There's another talk. People want to probably take some break.
Yeah, I can answer it. Like bad engineering culture would be top mistake. So it really affects a lot. Bad engineering culture, bad metrics can hurt you a lot. I think those 2 top mistakes. I will think what's the third one.
Okay, what does it take to develop ML algorithms to process large data sets asked by Sairam?
What does it make in which sense? Like what infrastructure do you need to build? What exactly?
What does it take to develop ML algorithms to process large data sets? Say if it's too large a data set, when you have to do the ML algorithm, you have to train, right? Supervised, unsupervised, how much to supervise, what kind of model you have to create. That's probably what you wanted to get an idea.
Like it's really depends on use cases. Like if you process, like if you train on large use cases, like typically in indexing, right? Yeah, it's too broad question. I can answer one line. There are like too many different methods depending like what your data set, what set of algorithms, is it NLP, is it learning to run, how you handle these different problems. Like do you apply sampling to subsample your data sets? There are different ways how you do this. I would be happy to answer offline.
Especially ML algorithms require modeling and creating the model, first understand the data set because it's too large. That's the point he was making, and so on, that I think you can answer offline as required.
Yes.
Thank you, Dr. Lopatenko, Andrei, for a great talk covering a lot of areas. We appreciate it. And we have another session starting at 10:50 and one more after half